Lesson 5.3, Pascal's Principle and Measuring Pressure. Pascal's principle says that a change in pressure applied to an enclosed fluid is transmitted undiminished to all portions of the fluid and the walls of its container. So we're talking a static fluid here, one that's not moving. And this is the basis of hydraulics. So if you look at this little system here, we have the smaller piston on the left and the bigger piston on the right. And the pressure stays the same. So we have F over A. If we change the area then, since the P stays constant, the force is changed. So if you have a small area, like the piston 1, it takes a small force. And then if you have a big area, like in piston 2, it'll supply a big force. So that lets you apply a small force to then turn around and make something a large motion, a large force. All right, how much force must be exerted at piston A to support this 850 kilogram little car on piston B? The piston A has a diameter of 17 millimeters and the piston B has a diameter of 30 millimeters. Well, we probably need these to be radiuses since we're doing area. So this one has a radius of half of 17 would be, well, that'd be 8.5 millimeters. And the radius of piston B would be half of 300, be 150 millimeters. Or if we put them into meters, get that. All right. So if we use Pascal's principle here, we have our force over area should equal our force over area. All right, we're looking for the force at A. All right, so that's our variable. Our area of A would be pi times the radius squared. The force at B, well, what would be the force at B? I know the mass, the force would be the weight. So our weight is our mass times G. And its area would be pi times its radius squared. Okay. So then we can cross multiply. So pi times 0.15 squared 0.07069 times FA equals pi times 0.085 squared times 850 times 9.8 or 1.891, and that is going to be a Pascal or something. And then we can divide and get our answer. So if we divide, we get 26.7 newtons. Don't think that was a Pascal. Anyway, when we divide, we get 26.7 newtons. So notice it takes a very small force. 26 newtons isn't very much to lift the heavy car. That's why we have hydraulics, and that's the power of Pascal's principle. All right, when we measure pressure There's actually two types of pressure. We have gauge pressure, which is used by pressure gauges, imagine that, and it measures the pressure relative to atmospheric pressure. So if you get, oh, it's 10 pascals, that means it's 10 pascals above atmospheric pressure. Absolute pressure, on the other hand, is the sum of gauge pressure plus the atmospheric pressure. So the pressure of absolute equals the gauge pressure plus the atmospheric pressure. One of the tools to measure pressure is an open tube manometer. Anyway, it is a U-shaped tube with a fluid in it, and it's attached to whatever you want to measure the pressure of. One end's connected to the container of which we want to measure the pressure. That's here. The other end is open to the air right there. And so the place with the higher pressure pushes that fluid down, and you end up with this column of fluid here. So that means that the pressure at 2 equals the pressure at 1 plus the pressure due to that fluid. Or pressure 2 is the atmospheric pressure plus rho GH. So pressure 2 is our absolute pressure, which means the gauge pressure would be pressure 2 minus the atmospheric pressure, or if you'd like, our gauge pressure would simply be rho GH. The tool we use to measure air pressure, or atmospheric pressure, is a barometer. Used to measure the air pressure, and it is a tube with the top sealed, so that top is sealed, and it's filled with mercury usually, although you can use any fluid. The bottom is open and sitting in a pool of mercury. So down here, that's open to the air. The pressure at the top is 0, because it's completely sealed. The pressure at the bottom is the atmospheric pressure. So that means that our pressure is just simply due to this nice column of mercury here, and that pressure is just rho GH. Changes in weather are often due to changes in air pressure. So there's high pressure. High pressure is nice weather, and low pressure is usually bad weather. And you can tell when it's changing because the air moves from the area of high pressure to the low pressure area. That's wind. And if there's a big enough difference, you get really strong wind. So let me pressure you into solving these problems and read section 11.7. Have a good day.